Hello children, I welcome you all to this class. Today our topic is law of conservation of momentum. Hope everybody know what is momentum. Momentum children, it's all about the quantity of motion that is associated with the object. Right now there is no motion with me, which means I have a zero momentum. And momentum can also be expressed as it's a product of mass and velocity. It's a product of mass and velocity. Since my velocity is zero, the momentum will be zero, right? And now, as I mentioned, today I am going to talk about the law of conservation of momentum. First, let me express it. The law of conservation of momentum can be expressed as the total momentum of the system remains the same when no external forces are acting on it. It can also be expressed as the total momentum of a system before the collision is equals to the total momentum after the collision. So let us do the mathematical formulation and have a better understanding by that. Let us assume that there are the two objects, two balls, okay, A and B, I have named them, of mass MA and MB. Let us assume that they are moving along a straight line with the initial velocity of ball A to be UA and that of ball B to be UB. And we also assume that the initial velocity of the ball A is greater than the initial velocity of the ball B. Since the velocity of the ball A is greater than B, there occur a collision between these two balls. Am I right? At certain point of time, the collision occurs between them. Yes, and during the, let us say the collision occurs for a time t. During that collision, both exert force on one another. A exert the push on B. Yes, at the same time ball B exert a reactional force on the ball A. Yes, so let me just write it as action and reaction. Okay, action, reaction, third law. Now I will just name these forces. Let the force exerted by A on B to be FAB and the force exerted by B on A to be FBA with a negative sign. I am giving the negative sign here since it is acting in the opposite direction of this force. Okay, and one more thing, the force which are acting is on the ball B and the force which is acting on the ball A. These forces are changing the velocities of the objects, okay, of the balls. Now after the collision, the ball A will have the velocity of VA and the ball B will have the velocity of VB. Yes, force has changed the velocities of those objects. Now according to second law of motion, yes, Newton's second law of motion, yes, we know that it is F is equals to ma. Yes, so similarly I can write the equation for it, that is FAB is equals to ma acceleration of A. Yes, and it can be written as ma as it is. Since acceleration is given by v minus u by t, so I just put the value of a here, that is v minus u by t of ball A. Yes, now let me just name it as first equation. Let me write the equation for this force now. FBA is equals to MA. It is of second ball. Okay, getting it? Now minus of FBA is equals to MB as it is. Again we put the value of v here, a here, and here it is of ball b. I will name it as a second equation. Now using third law of motion, according to third law of motion, third law of motion, hope everybody know what is the third law of motion. It says for every action there is equal and opposite reaction. Okay, let us say the action to be FAB and the reaction to be FBA, but in the opposite direction. Negative sign shows the force is acting in the opposite direction. Now we'll put the values here of FAB, that is MAVA minus UA divided by T is equals to negative sign as it is. Its value is MB VB minus UB by T. Here T get cancelled. So let me write the next step here. MA into VA minus as it is MA into UA is equals to minus sign as it is MB VB minus minus plus, okay, then MB UB, okay. So now last step I am going to write here. See here, last step, MAVA as it is, MAVA as it is minus MBVB I'll take to the left hand side, so it will take the positive sign. MBVB is equals to this minus MAUA I am taking to the right hand side, so minus turns to plus. MAUA plus as it is MBUB. It means, children, if you notice, what is this? It is MAUA plus MBUB. That is the initial momentum of the system. This is the initial momentum of the system, and it is equal to, see here, this is MA, it is MB, MAVA, okay, MAVA plus MBVB. This is the final momentum and this is the initial momentum. Means in the beginning I stated that the law of conservation of momentum, which says that the momentum before interaction is equal to momentum after the interaction, after the collision. So this is what the mathematical formulation of law of conservation of momentum. Thank you.